So we're here to talk today about the various levels of abstractions that we have in the Spring Framework portfolio on top of the Apache Kafka clients that the Apache Foundation provides. A little bit about us. I'm Gary Russell. I'm currently the project lead. Also project lead of the Spring AMQP project, which is our RabbitMQ implementation. And Soby?
Hi everyone, my name is Soby Chacko. I'm also part of the Spring engineering team, primarily working these days in the Spring Cloud Stream team, where my focus is on the Kafka and the Kafka streams, binders, and a few other ecosystem part of the Kafka support that we provide in Spring Cloud Stream. I'm the technical lead for the Kafka and Kafka streams binders, Spring Cloud Stream. Yeah.
Okay. So we just take a comprehensive look at the whole portfolio, and we have a few demo applications. We probably won't be able to get through all the demos because we have limited time, but Soby's put together a GitHub repo with a bunch of different demos that you can work through on your own. And then hopefully we'll have time for questions at the end. So what's involved in the stack? So right at the bottom, of course, most people, you don't have to use Spring Boot, but most people use Spring Boot. Then we have the Apache Kafka Java client, also the Kafka Streams client. Then Spring for Apache Kafka is our first level of abstraction, and we'll talk about that in a bit more detail. We have a layer in Spring integration, and sitting on top of that is the Spring Cloud Stream binders. And then we'll talk a little bit about the Reactor Kafka project. And it has a binder. So Spring for Apache Kafka, it's the foundational library for Spring's abstraction. It's for anybody that's using any other Spring messaging application or messaging framework such as Spring JMS, Spring AMQP, it provides similar abstractions. So message listener container for message-driven POJO invocations for incoming messages, the Kafka template for sending messages, similar to the JMS template or the Rabbit template, and as I said, it uses the Apache Kafka client. Now, from a Kafka Streams perspective, it's important to understand that the support is rather limited in that if you're using Kafka Streams, Spring for Apache Kafka gets involved with setting up those streams, but it's not involved at runtime. So it basically allows you to create Kafka Streams in a Spring-friendly manner. So getting into a bit more detail, we have a Kafka admin. So if you again, this is sort of modeled after Spring AMQP. So if you want to add topics programmatically, then you just add a new topic bean to the application, and Spring Boot automatically configures a Kafka admin. And Kafka admin, basically during application initialization, collects up all the new topic beans and then provisions those topics on the broker for you. That's obviously optional if you have an environment where your ops team want to set up the topics themselves. Kafka template is used to publish records. There are a number of different methods you can use in terms of whether you want just a simple, you're going to send a value, or you want to send a key with the value. You can indicate which topic you want to send it to, etc. Now, in all cases, Kafka is very asynchronous. The reason it gets such high performance is there's not really any blocking between the client and the broker. So we return a completable future for these methods, then you can either add a listener to those futures to get the result asynchronously, or you can get the result from the future, possibly with a timeout if you want to block. Okay.
One quick note, like if you want to know about more details about these things that Gary's talking about, we have links provided there, like the rough doc links. So if you click there, you can get to more details about all these various APIs.
Right. Excuse me?
Sure. Yeah.
Speak louder. Okay. So here's an example that getting an asynchronous result back. So we do a send, we're sending to a topic called topic, we send it with a key to partition 1 with a value data. I'm sorry, a key of 1 with value data. And then we just add a when complete method, callback to that future, and we'll get back the result, either success or failure. And that will come back asynchronously.
Next one.
Kafka template requires a producer factory. By default, the producer factory, based on the recommendation of the Kafka client Java docs, creates a single shared producer that's used across the application. The rationale there is because it's more efficient to do that. If you're using transactions, which we're probably not going to get into too much detail about transactions today because of the time, then there are multiple producers created because you can only have one transaction in process on a particular producer at the same time. So in that case, we would have a pool of producers. And as I mentioned, Spring Boot does a lot of auto configuration for us. So you can actually write an application out of the box by just putting a listener in there, putting a template, and Boot already creates the template for you. So he wires up a Kafka template, producer factory, consumer factory, listener container factory for consuming, and typically you don't need to override them at all. You can configure most things using the application YAML or application properties. So there's a link there to the boot reference. There's a whole section in the appendix of properties where you can see which properties are available. If you do enable transactions via the YAML, Boot will automatically configure the environment for transaction support. On the consumer side, this is similar to JMS listener, Rabbit listener. We have this @Kafka listener annotation, which you put on a method, and that triggers the framework to create a listener container. It requires a listener container factory to create that container, and as I said, Boot will auto-configure the factory for you. We simply can say, you put it into you give it an ID. It's a good idea to give it an ID because you can control the life cycle of these listeners. You can stop, start, pause, resume, etc. using that ID. There's a bean that the framework provides called the Kafka Listener Endpoint Registry, and you can get a reference to these listener containers using the ID from that registry, and then you can perform many operations on those things. And as you can see, it's very simple. In this case, we're just getting a string value in a simple POJO method. Message listener container is, as I said, that's really a Spring concept across multiple projects. It basically takes the work out of your hands for dealing with, communicating with the broker. It provides a simple POJO interface where you just push messages to your POJO. You can either receive a single message. So when basically Kafka works, we poll the broker, we'll get a bunch of records from the broker, and then we'll call, usually by default, we'll call the listener one record at a time, and you can process that and go. Or you can configure it to receive the whole batch. You receive a list. In that case, the method signature would be a list of some things, and you will get the whole batch of records from that. We have two containers. There's the Kafka message listener container, which is just for if you've just got one thread. And we have the concurrent listener container, which actually fires off multiple Kafka listener containers. This allows us to add concurrency to the application, so you can receive records from multiple partitions. It's important to understand that the way Kafka works is you can only consume from one partition at a time. So if you've got a concurrency of 10, you need at least 10 partitions on the topic. Okay. This is a rather complex subject. Kafka only maintains 2 pointers. It maintains a position, the current position that this consumer is in, and the committed offset, the last one that this consumer has said that he has processed successfully. they're really unrelated, except when the application first starts, the position is set to the last committed offset. So what we do, as we're consuming records, we go through and we commit the offsets to say, okay, I've received this one, I've done this one. And there are a number of different options, whether you would commit after every record, or you commit after the whole batch, which is a little bit more efficient, but you could get some duplicate deliveries in that case. So it's a trade-off from a performance and a functional perspective. But there are a number of different, documentation goes into the various options. Now, Kafka itself provides this property called enable auto commit. By default, they turn that on, which means the Kafka clients will commit the offsets at some indeterminate. It's not really indeterminate, but it's after some configured time. Now, we prefer that to be turned off because the container will commit the offsets in a much more consistent and deterministic fashion. By default, if you don't do anything with that property, Spring for Apache Kafka will turn it off. If you explicitly say, I'm going to ignore the advice and I'm going to use that option, then if you've explicitly said it's a true, then we'll honor that. During application initialization, you can enable actual seeking. So instead of starting at that last committed offset, you can seek to any particular offset within that. A lot of people store the offsets in an external database, so they might want to use that to then reset the offsets when we next start the application. The framework provides a number of convenient ways of doing those seeks as to whether you want to do them during initialization or whether you want to do them at runtime later after the application has started. And there are a couple of options if you go back. You can either, you can basic seek to the beginning, go all the way to the front of the topic, go all the way to the end, or you can seek it to a timestamp, which basically says, I want to receive all records that were produced after a particular timestamp. The next important function is error handling within the container. The user typically does not have to deal with errors. Your user code can purely concentrate on business logic. You throw an exception, the error handler will take care of handling that error depending on how you've configured it. By default, it will just replay that same record 9 additional times, so 10 attempts total, and then finally just log that we couldn't process this record. But there's much more sophistication available. We have a thing called a dead letter publishing recovery, which says that after we've run through all these retries, write this bad record, write this poison record to a different topic, move on, and then we'll deal with that, or you would have to write some code to deal with that problem later. But it's quite sophisticated in terms of whether you want to do exponential backoffs between each retry, and we'll talk about a little bit more sophisticated retry mechanism a little bit later on. So this is how you would configure it. There's a default error handler here. We give it a recoverer and a backoff. This is I want to back off for 2 seconds, and I want to have 2 additional retries. And in this case, we're injecting a dead letter publishing recoverer, which is previously configured as another bean, which allows the exception to be run, the failed record to be sent to a dead letter topic. We got some fairly additional sophistication with what exception types are retriable and what are not. So you can say, well, and there are certain error conditions that the framework just by default considers fatal. So like if you get a conversion error, so we couldn't convert the incoming data to the type that your listener expects. If we get something like a class castic, so like something where retry doesn't make any sense. It doesn't make any sense to retry because it's going to fail on every retry. So we configure a number of default exceptions that just say we're just not going to try and retry this one. You're at complete liberty to change that list, add to it, remove it, or whatever. But again, the Java docs provide detailed descriptions about that. This one's quite important. So when we configure a Kafka consumer, we provide it with a deserializer. Deserializers take the byte data that comes from the broker and converts it to some object. You might use a JSON deserializer to convert from a JSON payload to some kind of a DTO. You might use Avro deserializer or any kind of deserializer. The problem with that is if that deserialization fails, Spring has no control over it because it happens before we get the record, right? So there's nothing we can do. We're not even told. You end up with this loop. It says deserialization failed, and there's nothing. You got to move on, like move this consumer past this record. So we created this error handling deserializer, which basically says, I'm going to use a JSON deserializer, but I'm going to wrap it in an error handling deserializer. In that case, what happens is the error handling deserializer catches the error and actually writes the deserialization exception to a header of the record. The record is passed up to the container, and the container detects that header and then sends it directly to the error handler. So the listener doesn't get that bad record, it just goes straight to the error handler. And then it's just handled in a normal way, except it's a fatal one because there's no point in retrying deserialization. It's fatal by default. So again, you might write that to a dead letter topic to examine later, understand why we couldn't deserialize that record. But I think this is a pretty big value add because it really is a tricky problem when you write your own Kafka code to deal with these problems. And again, I can't go into full detail because of the limited time we have, but we have quite a number of error handlers. When you're using a batch listener, we have a number of batch error handlers. By default, it's kind of difficult with a batch because if you receive 10 records and you fail on the 5th one, the framework's not going to know which record failed, right? So all the framework can do is give you the whole batch again, right? But we do have some hooks in there that if you throw an exception that says, this batch failed, but it failed at the 5th record, then that allows us to commit the offset of the first 4 and then just give you the 6 or the 6 plus more records on the next go around. And then we have this notion of non-blocking retries. This is, now a lot of Kafka applications rely on strict ordering. So everything in a partition is in order, right? You don't want to process these records out of order. We have this non-blocking retry mechanism where if strict ordering is not important for you, you can, when a failure occurs, instead of blocking and retrying and waiting, for however many seconds to process that record, we just immediately write that to another topic and then move on to the next record. And then the other topic has a delay associated with it, and then we deliver that, and you can configure however many retries, same thing with exponential and fixed backups and stuff like that. And eventually, if it fails all those retries, it goes to the dead letter topic. We also provide for testing. Now, a lot of people these days are using test containers, which is just fine. This kind of predated test containers, so we provided an embedded broker for writing your unit or integration tests using Spring and using this embedded broker. So we just fire up a broker in the same JVM as the test, connect to it, set up the Spring boot properties to make sure that if it's a boot application, boot can talk to it. And again, it's extensively covered in the documentation. We have request reply mechanisms, so where you can do a send and receive on a subclass of the Kafka template, where you've got a server that receives the record, does some processing, and returns it back. So we have and that's an async request and reply, where you get a future, and then the reply comes back as a future. Transactions I mentioned briefly. and I also mentioned briefly Kafka stream support. As I said, it's fairly limited. It just helps you set up those streams quickly. And then Spring integration is a Spring. If you're not familiar with the Spring integration project, that covers a whole series of technologies, but in essence, it's our implementation of the enterprise integration patterns, and we provide Kafka adapters. They're based on Spring for Apache Kafka, and we provide these adapters, which are adapters for one-way integrations with Kafka, and request reply via gateways. Again, that's for people that are using Spring integration in other scenarios. So if you want to read from a rabbit queue, for example, and write to a Kafka topic, you might consider using Spring integration for that. Next. Yeah, let's just go through the adapters. I think I'm going to hand over to Soby now to talk about the Spring Cloud layer on top of Spring integration.
Oops.
Again. Okay.
Yeah, all right. So Spring Cloud Stream, as we indicated before, it's part of the Kafka stack that we provide as part of the Spring portfolio projects for Apache Kafka. So something briefly about Spring Cloud Stream before we get into the Kafka part of it. Spring Cloud Stream is actually a framework that allows you to write like event-driven microservices in like a messaging neutral way. So if you want to write your application for Apache Kafka, you can do that, or RabbitMQ, or Pulsar, or any other cloud-specific brokers out there. This framework allows you to do that in such a way that you don't have to really think about your underlying messaging broker. In other words, let's say your enterprise's goal is to get the application, done in a faster way. It gives you that velocity because it abstracts a lot of things otherwise that you have to worry about, yourself. But I guess by all means, if you really want to get into the lower level of the spectrum, things like Spring for Apache Kafka or similar frameworks from the Spring portfolio projects allow you to do that. But if you want to stay at a very high level of abstraction, Spring Cloud Stream allows you to do that. It's based on the programming model exposed by another project called Spring Cloud Function. If you attended the keynote today, Oleg Zrakowski talked about that. So the entire programming model of Spring Cloud Stream is built on top of Spring Cloud Function, which means that you can really write your messaging processor or your supplier using Java 8's Lambda support. For example, you can write your application like a Java util function or a consumer or a supplier, and that gives you immediate, benefit of, writing your microservice in such a way. So the Apache Kafka support in Spring Cloud Stream is actually built on top of Spring Boot, as we saw in that initial diagram. All Spring Cloud Stream applications are boot applications. When you use Spring Cloud Stream, you cannot opt out of Spring Boot. In the case of Spring for Apache Kafka, if you don't want to use boot, you can stay at the core, basic Spring framework level if you want. But in the case of Spring Cloud Stream, you really have to rely on boot. So Spring Cloud Stream Kafka support specifically built on top of Spring for Apache Kafka, and the Spring integration support that we saw in the previous slides. So it's sitting on top of the messaging channel adapters, as we're going to see in the next slide. So this is the programming or the application architecture for a Spring Cloud Stream application. So if you look at it, your Kafka broker resides at the very bottom of the stack. And then on top of that, you have Spring for Apache Kafka comes in. And then depending on if you're using Kafka streams or plain Kafka producers or consumers, you have the Spring integration, or Kafka streams comes into the picture. Then on top of that, Kafka and Kafka streams binder in Spring Cloud Stream comes into play. And then your application seeding it's actually on top of that. So if you look at it, the stack is kind of deep. But again, the benefit is that your developers, if you're a developer, you work at the very top of the stack, so that you can just focus on your business logic without thinking conceptually about how things work at the bottom of the stack, because your application will communicate to the binder using Spring integrations, input and output channels in the case of the messaging channel binder. So briefly about the binder here. So the Kafka binder in Spring Cloud Stream, we have two kinds of binders. One is the message channel-based binder, which is Spring integration-based. And then there's another Kafka Streams binder, which we'll see later, but that is not going through the Spring integration route. So the benefit of binder is that it does automatic provisioning of your topics. When your application starts, it creates the topics for you based on the configuration properties that you provide. And then Spring Cloud Stream provides various bindings. Let's say you're writing a producer application. Then it creates an output binding so that it can write into a Kafka topic. If you're writing a consumer application or a processor application, then it provides both input binding and an output binding so that you can consume from a Kafka topic, and then on the outbound, you can publish to a Kafka topic. And then Spring Cloud Stream provide message conversion in the Kafka world. It's like the serialization, various serializers and deserializers in the form of Spring's message converters. And then Spring Cloud Stream provides DLT support. Gary mentioned about error handling at the Spring Kafka side. So we, in the Spring Cloud Stream world, we kind of leverage on that and then build a specific DLT support in Spring Cloud Stream. And then because Spring Cloud Stream is a boot application, Spring Cloud Stream gets all the benefit of boot, such as if you want to have actuator endpoints or health checks or micrometer-based metrics and things like that. All those things are available when you're using the Kafka binder. So here is a quick programming model of how a Kafka binder-based application looks in Spring Cloud Stream. If you look at it, there is nothing Kafka-specific in it, right? So what you're seeing is a plain Java util function supplier, and then a function, and a consumer. And then if you look at the last one, there's something Spring Cloud Stream specific, Stream Bridge. It's basically abstraction for if you want to send something offhand to a Kafka topic without relying on this Lambda-based programming model, you can use that using Stream Bridge. So if you look at it, it's fairly simple. If your developers have the common denominator of Java, then this is a great way to look at it. But on the other hand, if you really want to get into the depth of things, sure, you can, even in Spring Cloud Stream level, you can actually get into the actual Kafka details, via Spring for Apache Kafka. So this is the programming model of Spring Cloud Stream from a very high level. All right, moving on to the Kafka Streams binder, Spring Cloud Stream, using the support of Kafka Streams that Gary mentioned in Spring for Apache Kafka, essentially from the Streams Builder factory bean, Spring Cloud Stream builds a dedicated Kafka Streams binder. Here the thing is that it doesn't go through the message channel support in Spring integration, but rather it binds directly to the Kafka Streams types such as K-stream, K-table, global K-table, and things like that. So on the input and output, normally if you write a Kafka Streams application, you have to basically define your SERDs and for both input and output. But the binder does like automatic inference based on your functions, signature, and things like that. Now for stateful applications, Kafka Streams has this interactive query support. So the binder has like a dedicated API called interactive query service, using which you can actually query the state of your application, your data, and things like that. Then you can have multiple functions in the Java. Using the same Java function support, you can compose different functions, you can query functions, and things like that. All right, here's a quick look at the same sort of programming model. What you're seeing is a Java util function where your input is a K-stream and then the output is a K-stream. If you write Kafka Streams application, you know that this takes a lot of boilerplate. You have to write a lot of low-level code to make this happen. But the binder sort of abstracts all these details for you. You don't have to worry about writing all those things. All right, so here is all the resources from the Spring side. You can find Spring for Apache Kafka, the Spring Integration Kafka, Spring Cloud Stream details, and the Spring Boot Kafka doc. So if you get to the slides, all these links are provided there. right, so that's all the talk that we wanted to do. So here is the repository where we're going to demo a few things. So since this is like a walking through the entire stack kind of talk, we sort of prepared a few sample. Oops, hold on. A few sample applications here in this repository. So it's called S1 2023 Kafka Stack Demo. So basically, we have 12 short samples there. So the way we organize this repository is that if you go to the repository, there's a README associated with it. So for each app, we put a small description how we can run this app. So these are like very simple apps, not very complex. So if your goal is to just try to understand how these things work, please feel free to go to the repository. Try to run this app. We provide like a Docker Compose script where you can start a 3-node cluster locally if you want. So we're gonna just run a few apps here. We don't have time to basically go through all the apps here. We're gonna pick like 2 or 3 from these samples. And then after that, we'll go into some questions. So the way it's named is that by looking at the name of the sample application, you know what project it's referring to. So if you say Spring Kafka app, you know that's exclusively for Spring Kafka apps. And then there's a Spring integration section. You can see how Spring integration Kafka support works. And then there are a few Spring Cloud Stream apps that shows both Kafka and Kafka streams binders. So let's look at this, the very basic application here. So Gary went through this Kafka listener. So what we are doing is we're basically consuming from a Kafka topic and then just print that. And the type here is string. And then on the Kafka template side, we're just publishing like some information. I'm using the Faker library to just quickly generate some data. So if you run this app, I'll show you where I run the Kafka instance. So it's all Dockerized 3-node cluster here. So when I run this application, it's like a Spring Boot application. So it creates the topic. So when I run this, what we see at the bottom is that basically it's actually publishing 100 times some fake data is generated, and then on the consumer side, it's getting printed. So that is the very basic Spring Kafka app. Like I said, we don't have time to go through all the apps here, but I want to briefly show you this Spring Kafka 4 app, fourth one, because that's the one that talks about the error handling stuff. So essentially, here we have a listener, and then we are basically, contriving a scenario here, like if the offset is 9, we just throw an exception. So when we run this app, what's going to happen is that we have that default error handler being defined with the recoverer. Recoverer is actually publishing to another DLT topic. So I'll quickly run this application and then and see how it works. So I have 2 listeners here. The second listener is actually listening from the DLT topic. So when we run this app, we can see that if the offset is 9, oops. Okay, I ran this right before this presentation, so I don't know. So, all right, something is not working there.
Demo gods.
Yeah, that's right. Sorry.
Using
Yeah.
the same topic.
Yeah. No, it's probably the. All right. So moving on, something minor, I'm pretty sure. So we'll figure that out. But I want to show you this app 7. Gary added this non-blocking retry sample. So. That's pretty interesting. Gary, you want to just talk about this?
Yeah, this is, I mentioned that non-blocking retries. So what we do for non-blocking retries is just add this retryable topic annotation. And this says we're going to try 5 times, we're going to back off 2 seconds, and then multiply that by 1.5 seconds each time.
Yeah.
So if we run that,
yeah.
you can see, can you enlarge the text at the bottom?
Yeah.
So, scroll to the left a little bit.
Sorry?
Scroll to the left so I can see the right side of the screen.
Yeah.
See, we can see we've received. No, scroll. Sorry, scroll. I should drive. Yeah, so we can see here, as I said, 1 was received, but when we receive 1, we throw an exception, right? So 1 was received and we threw an exception, but 2, the next record in the topic, was received immediately. But then 2 seconds later, we received the first retry, and then 3 seconds, because the multiplier is 1.5, and then 4.5 seconds, and then 6.7. So we went through these non-blocking retries. Those containers, if they had other records in between, they would be processed.
So I'll quickly show you. I won't run the Spring Cloud Stream app. I don't think we have time because we want to give some time for questions and answers. So here is the application, the basic Spring Cloud Stream app. So we have a supplier here, a function, and a consumer. So if you look at the configuration for this, you can see that this is where the binding happens. So all the communication on the Spring Cloud Stream side is happening through like input and output bindings I mentioned. So in the supplier's case, it's actually producing data, and then that data is consumed by the input binding for the second function, and on its output, it's publishing data, and then we have another third consumer here that is received by that consumer. Let's see if we can run it real fast, and yeah, so you can see that it's constantly streaming data. The supplier is producing data, a function is receiving, and then it's basically converting that into something else, and then publishing that, and on the consumer side, that's being consumed again. So again, we don't have time to go through more apps here, but please feel free to go to that repository one more time. Here is that again. And
it's a regular GitHub repo, so if you have any issues or have any problems understanding any of them, then just open issues against.
So here is a QR repo code for the sample repository. If anybody wants to get to the QR code, you can go there. With that, we'd like to.
We've got a couple minutes left for questions, if there are any.
Any questions, comments, concerns?
Is it all clear, or clear as mud? Okay.